Welcome, everyone, to the second Waku Internal Hackathon of the year. I am your host, Chair. I will be bringing the presenters on and the panelists for feedback rounds after their presentations. We have 3 presentations for you for this session. We are live on YouTube and Twitter, and your likes and shares and follows with notifications on are appreciated. We can see the action in the chat, so wherever you are watching, if you have a question about any of the presentations, please do submit them there and we will see them and provide feedback. Without further ado, let's get right into it. I'll bring on our first presenter. It is Fabiana. And as I cycle the view, the stage is yours.
Hello. So my name is Fabiana. I'm a Waku engineer, and this is my Hackathon Week project. So my idea was to restore fun to home hashing. So if you remember the early days of Bitcoin mining, everyone at home, they could just run a Bitcoin QT, a mining program, and it would get tokens, and that would be that easy. This was ruined by hardware acceleration. So SHA-256, the Bitcoin hashing function, can be accelerated up to 200,000 times with ASICs, for example. And this makes your home computer no good for participating and getting tokens, right? But with recent newer secure hash functions that are built to be proper VTFs, you can actually use your CPU again. So Monero has RandomX, which is pretty good. And so we can have fun with this again. And the idea is not to use proof of work necessarily as a way to secure the system, like to secure a blockchain, to stamp blocks. The idea is to use it simply as a Hashcash system, like as originally envisioned by Adam Back in his Hashcash paper. And Hashcash is like the foundation for Bitcoin. And it's a very simple system where you can mine a message with RandomX with a secure hash function, and the receiver can know it's not spam, right? So, and in this case, we would use it to some digital system would receive the message. It can be a blockchain, it can be a website, it can be a chat application, it can be anything. It receives the message, and it can grant tokens based on the difficulty of the hash, right? And the goal here, again, is not to secure a blockchain, is to just have like the zero friction, fun, risk-free way to participate economically in any system, right? So no account setup, no login, no identity, and even no software installation, because you can actually run this miner in Wasm. So my demo is I built a mock of a proof of work Hashcash system on top of Waku. It has a single message structure. I will not get into the message structure. This is just the design. The semantics are very simple. The message has a public key that signs the message, and a proof of work hash that can be verified by any receiver unilaterally. And if the target difficulty of the mined hash is 200, you grant it 200 tokens. If it's 400, you grant it 400 tokens, and so on, right? And atomically inside the message, you also have a payment, so you can specify another public key and an amount that you will transfer to that account using the tokens that you had allocated to this public key. And the system is super simple. It's entirely decentralized. So nodes just collect these messages, collect these like chat messages, for example, and they sort them in timestamp order. And a ledger is basically a replay of the messages. That's it. It's pretty simple. So what would be the security of the system? Well, there is no spam because it's a Hashcash system. So it's entirely spam protected. Message ordering by default is determined locally by each node without any need of like coordination, consensus algorithm, or anything. You just don't accept all the messages, so that's how you keep the double spend database in an acceptable size. And if you join late, you have to retrieve old messages from some trusted node. Again, this is not a blockchain. This is a very, very simple system. So, for example, attackers can simply easily fork their own messages. They can craft a timestamp that is close to the deadline of 20 minutes there, for example, and then half the network will accept the message and order it, and half will reject, and so you just fork your own message. To solve this problem, you could implement consensus providers which are opt-in, and this would be guaranteed by like higher level protocols. So you could actually connect to one or more nodes that are providing a service that providing some kind of consensus, and users can actually choose which consensus providers they would use. But even if you don't do that, the system, just as described, you can have entirely stateless transfers if the Coinbase amount there that you mine in the message is greater than the amount that you transfer inside the same message. So you could have, let's say, you could create a very simple system where you have some API node, and you have an API key there with this free API service, and you send proof of work tokens in the chat medium, and the API node just sees messages individually. It doesn't even order messages or have a message history. It just takes messages individually, sees that the proof of work is correct, and that it is being paid inside the same message, and that it just regenerates like accesses in your API key, right? So what would you use the system for? Basically for all sorts of chat applications and extensions, like you can have games, completely decentralized games that have an economy. They can use this token for the economy. Test nets, demos, tutorials, you can use this to get started really quickly. It's also fun and risk-free entry into blockchain token economies, because you could have like a crypto faucet bot that participates in the system, and you can feed it proof of work tokens, and it would grant you some tiny amounts, your first amounts of crypto you could obtain entirely with like hashing at home and chatting, basically. And the more interesting and actually more intense implementation of the system would be as a full-blown Waku POW relay component, where you could have an open network that's protected by this. And it's spam protected, and it's spam protected in a completely zero conf way. So ideal for like writing tutorials that explain, oh, you can use this open network to connect your tutorial to, and it just works because you can actually leave it in the open because it's spam protected. And if you do that, actually, you don't need like a application level command to like mine. You just chat and you're automatically getting tokens, because to send messages at the relay level, you're already wrapping it with a proof of work like encapsulation, right? So the demo is really, really simple. I'm just going to go through it really quickly. I had to mock everything. I couldn't actually get it to like a mature point, but it gets the point across. You can see what the experience would be implementing this at the application level. There is this C++ implementation of RandomX that I made. You can look into this. So this is a working RandomX integration, and some supporting articles on why these economies that would have like these very tiny values produced by these proof of work tokens, what would that be good for, and why that would be fun. So I wrote some articles to support this. And so let's just jump into the demo. So this is a full-blown mock. Everything is mocked. It's just to demonstrate that you could go these two chat clients participating in the system. That would be the user experience. You would say, I don't know, I want to mine 100 tokens. This would be broadcast in the system, and then you would have a balance immediately. So it would pause a bit because it would mine. And this is a substitute for a public key. It's just a port here. And I have 100 tokens. This is just the result of playing this message. Then you can go into the other one and get 200 tokens. And then, as expected, it's just the same balance. And you have messages ordered by timestamp. The mock has some sophistication. It deals with straggler messages. So if you receive a message out of order, it would sort. But if you look at the implementation of this, is really tiny, right? So it's very easy for anyone to implement this as a, like, let's say an extension or a plugin to status community, for example. It would be like very small amount of code, and you would equip any chat room with this kind of economy. And that's it. So Anybody has any questions, ideas?
Absolutely. Thank you, Fabiana. Let me bring the panelists up one by one. Questions, feedback.
So thanks, Fabiana, for that. So if I understand correctly, the idea here is to attach a proof of work to the messages for token creation and token exchange, right? So I'm just trying to like place that with what we're doing with RLN and rate limiting. And I don't know, have you thought what would be the difference between using the cache hash for proof of work and spam versus RLN?
Yes. So RLN is the industrial strength solution. It's like it's an awesome system, right? The difference is that it doesn't have like zero setup. So like a tiny amount of setup. It's getting better as the tooling matures. But let's say I'm going to write a tutorial, right? And I want this to be like something that's very quick for people to get in. So I can, if this was to be implemented as a POW relay, this could actually be implemented from the outside, right? So if some contributor wants to contribute a POW relay standard and an implementation, this would be actually ideal for external contributor team, like 2 or 3 people to do. This would be a super fun project, right? So you could create a proof of work relay, and then the experience is that you would type some message and it would pause a bit and then send it, right? Because it's mining. But you didn't set up anything. It just works. So the tutorial that you would write about this, it would be like very tiny. It would be zero setup. So it would work like right away, right? But it's not ideal, right? So you don't want to pause before you send a message. It's not like a panacea. So I actually think the superior approach is still RLN and using some kind of identity system, which is being looked into right now, because you can use people's unique identity to grant them tokens also, right? But identity is also not zero setup. So this is just the quest to have a mode of operation of the software that is purely zero setup. But by itself, it's not that interesting, right? Okay, we have a proof of relay. And then I realized, actually, you can hook this up with an economy. So there is you can play a lot with this, right away. So these proof of work tokens can actually generate application level tokens that you can reuse in games. So you can have little games where you can have these gems that you can spend and everything. You can implement these games entirely, like let's say in JavaScript on top of any chat application, like as an extension or a plugin. So you could have hundreds of little mods. Like I imagine this like as the Roblox of crypto, right? So it's just playing with the concept of tokens. This would be entirely safe. So you could have like, I don't know, high school students learning about owning tokens and generating tokens with zero economic stake. It's just like you're using the rate limiting aspect of these proof of work tokens, which is the original Hashcash system. And the relay just works, but it's actually pausing before you send a message because you have to compute these hashes. And you're using CPU, so it doesn't work on mobiles as well. So it's not like perfect, but it has the zero conf aspect that you can recycle at the application layer to get all this fun with these. You can recycle the proof of work that you use to protect the network at the application layer. So I think that combination could be really powerful. So.
Thanks.
So can I go next to provide my feedback?
Yes.
Awesome. I hope you guys can hear me. First of all, thank you for presentation, and I really like the idea. Right? Unfortunately, probably I don't understand all the details, but general idea I really like it, and especially when you mentioned that we can use it in status application on communities in terms of fighting spam. And I'm just curious to talk a bit more about this use case, because this one is interesting. And like you mentioned, it can be set up really easy. And I'm wondering if you can turn this kind of idea into sort of a prototype that you can try with the status app. The biggest question that they have from the user experience, how that system look like. For example, I'm a user, right? And I try to spam a community, right? I'm trying to send tons of messages in a short interval of time. How they kind of be stopped, prevented by this system, right? And what other users that are, let's say, using this community, how they gonna experience it? Do they see anything, any kind of signs of that?
Well, there's the Frankenstein version of this where you're using RLN to protect the network. And then, as I showed you, implement this entirely at the application layer. So Waku and Status don't even know about this, but then you stack something on top, that an extension that allows you to send a message to this network that has a stamp attached to it. But this is at the chat application level. So when you're specifying that protobuf message for your specific application, you're adding some metadata fields there that allow you to optionally attach a proof of work to it. But then you have the network protected by RLN already. So that would protect the chat itself from spam. So that's the lightweight version and prototype that you can actually pilot the idea that this is fun at the application level, like super quickly. But then you have the power version of this where you say, actually, we are moving the stamping to the relay level, right? And then the relay is protected by this, and to send any message in the Waku network. So Waku upwards is already, you're actually protecting messaging spam in the system using this. And then at the application level, the stuff that you would write there to mint and whatever is missing because you don't need that. You just look at the metadata, the headers of the relay, and that automatically you just consume those and maintain the ledgers at the application level. So there is two ways to implement this, and both are spam protected. If you are using this to actually protect the network in spam, you have to be very careful with the difficulty targets. So you're going to say, so per character in the low-level message, you will have some difficulty target per character. So if you say hi, maybe it pauses for like half a second to mine. But if you send a 100 kilobyte message, it's going to mine for an hour. So it's not very usable there, right? So because you see, that's how you don't get spam, because you're protecting the actual network, like at the byte. It's like gas, right? And just like in Ethereum, how do you protect the Ethereum state? Why is Ethereum state manageable? Well, you have to pay $1,000 per kilobyte, right? That's how it doesn't have 100 petabytes now. And this is the same logic that you're using. You're tuning it to be quite aggressive in the kind of work that you demand from the stamp. And the fact that RandomX is so good at preventing hardware acceleration is what guarantees that the hash cache system is actually usable, because when Adam Beck published this paper like over a decade ago, like hash cache system to protect email spam, it didn't work with, because if you use, like, I don't know, existing one-way hash functions, they're all meant to be very efficient. And so they're very easy to write an ASIC. So anyone with an ASIC can spam the system. So you say, oh, I'm going to put a large proof of work target, but you use an ASIC and you can spam, right? And if you put a target to prevent ASIC spam, then nobody can use the system because your CPU cannot mine a message. It's 5 weeks to mine a high message. So,
I see.
But with the RandomX is a true marvel of computer science. I'm amazed by this project. So they actually wrote a one-way hash function that can hash data one way. It's a secure hash, but it's massively inefficient. And it uses 2 gigabytes of RAM in the verifier, and it takes 20 milliseconds in my computer to compute one hash, right? And this completely destroys ASICs. So now now it's a reality. We can have a hash cache system because we couldn't have one before, right? Bitcoin adapted to this because Bitcoin doesn't care if there's ASICs in the system or not. It doesn't care about CPU, but we do. If our goal is to have a true hash cache system with the newer VDF-like secure hash functions like RandomX, which are actually work and they're great, we can use this as a gateway into having tokens, and even use it as a relay, which is never going to overcome something like RLN. RLN will always be the superior choice. But for like an entry level, like, oh, I just want to set up like with zero setup, just let's do Waku Node 2 -- POW relay, just get something really quickly going, just type 5 seconds, it would work, right? So we would save you some setup steps, and that's maybe an entry point. But for sure, if you want the real version of this, you're going to use RLN, right? So.
Got it. Yeah, thank you for explaining this. And based on this idea, you see that this particular tag might be helpful for testing applications, or
So for example, you could use this if we had this working. You could use this to buy an RLN certificate, right? So you could mine this proof of works, and then you would have a bot in the chat that would sell you an RLN subscription. You could do that chatting, and you would say, oh, this is my key, whatever, and then it would be like this interactive, and you would be chatting with people as you do that as well in the same status community. So it's like this entryway into the whole, I have tokens, I need to be rate limited, and it's really slick, right? So you can do this from one unified interface. So I think that's one idea. And just to mention, I think like there is like this marketing and business people. I think they would see this as a way to also spawn an entire ecosystem with a click, right? So you could create a status community that it has a token in it, and then people can play with it, and it's immediately tokenized. So this is a way for people to understand tokenization before they understand blockchain also. So I think this would be pretty cool.
That sounds really awesome.
Yeah.
Roxana, do you have a query?
I have a query. I guess I'm just thinking, if someone were to build Nostra on Waku, what would be the highlights of your project? Why would we opt for what you're building versus a Nostra on Waku? Because Nostra was also inspired by Hashcash, so they built a lot of the initial thesis of Hashcash. They've integrated into Nostra.
Sorry, I didn't catch that. There is a team that already did this idea? Is that it?
No, we always look at Nostra. So we always talk about building Nostra on top of Waku, because this is why Nostra would actually be much better. So I'm just thinking out loud, because Nostra was built on the initial Hashcash vision, so to speak. So I'm just curious of the stuff you're building versus having a Nostra on Waku. What would be like the core benefit?
Oh, I'm sorry, I'm just not familiar with Nostrum, but maybe they are doing the same thing. And if they are doing it, I'm imagining they are doing it at so they are gonna do that on top of Waku. Is that it, or it's a separate?
No, it's just it's like
I'll jump in, huh?
Yeah, if you can.
Question, yeah. So Nostra is kind of dynamically federated. So each relay. So as a user, I connect to a bunch of to maybe 2 or 3 relays and I start to post on these relays. And I can tell other users, hey, if you want to follow me, my messages are on these 3 relays, and so you can follow me on any or all of these relays. And so if your relay goes down, you still have 2 relays remaining, but it's quite federated. Like the relays is someone who deployed in a website. So it's up to the relay to decide whether they want to store messages and how they want to do it. So some of relays just run for free, and we store your messages for free, or we store your, maybe up to 10 megabytes of messages for you for free, and some other relay will get paid. And so you can pay via Lightning. You can pay a relay to say, hey, I'd like to have a message stored on you. Here are some payments via Lightning. So they don't really use Hashcash nowadays. It's more like each individual relay may or may not accept payment, and what form of payment is really up to the relay. Yeah. So they could have, so they could use it if they say, I accept store messages for free, but every time I want you to attach a proof of work. And so then this applies again, right? So you could generate a proof of work, send a message with proof of work to the relay, say, hey, here's my message. Please store it so that people can subscribe and see my messages.
Yeah, so I'm not really sure what's the exact difference. I mean, this is a very general purpose idea, right? So I'm not the first person to notice that we can use the newer, more VDF adequate one-way hash functions to implement an actual hash cache system now that's actually democratic. And this can be used in a lot of ways, right? So this is just one way we could do it native inside of Waku. And then, of course, from there, once you have basically a Waku shard being a quasi blockchain, and it's money aware, so to speak, right? So then you could use this to like pay for storage, and you could do this all like Waku native from a very low level, right? And I'm not sure if that's exactly the route other projects are going. I would imagine that other projects would get to the blockchain point really fast, so they would try to hook up to a blockchain, because this is one thing you can do with this project, right? So you could have a smart contract on a gasless L2, collect these proof of work stamps, and grant you ERC20 tokens. You could do that, right? Instead of implementing it as this completely decentralized ledger that you build security slowly, but it actually runs on Waku and it's not a blockchain. So, but you could do this in a blockchain as well, and then you could use that Hashcash function to generate these tokens, and then you could use them to buy relays and everything, and buy message storage. So this can be implemented in a lot of ways. So this is to be seen how we would actually use it or not.
Alrighty, Fabiana, if you could put the screen where with all of the links to the repo and the demos.
Oh yeah,
and whatnot.
Yeah,
and just for everyone for their quick screenshot references. Thank you very much.
Thank you.
We will bring up. Okay, it looks like Ivan is good to go. So we'll bring on Ivan and say goodbye for the moment to our panelists. And we have Ivan. Hello, welcome to the stage. Do you have a screen share ready to go?
Yes. Hello. Congrats, Fabiana, for the presentation. By the way, is it visible, the screen? Yes.
It is. We have an infinity
Okay.
situation, but alrighty.
Okay, cool. Well, in this presentation, I want to share possible open gate for new applications or new mechanism to be developed. Something that we had a request that we had in the past within Waku was related to build applications and integrate Waku within Flutter. For those that you are not familiar with, Flutter is a platform developed by Google, I think, and the main idea is to keep the same code base and be able to deploy easily in multiple platforms, mobile, desktop, and web. And in this particular presentation, we will focus only on mobile and desktop. Yeah, I wanted to implement something a bit more mature, but I didn't have time. And the fundamental idea, let me first of all start the Okay, this defines the main application. This defines the usual structure of an application implemented in Flutter. It allows to perform binaries for iOS, Android, Linux, macOS. And in this fundamental example, what it does, it integrates another project, which is Waku Dart bindings. Something that we use nowadays in Waku, and a mechanism to expose the current NIM Waku implementation to other languages is by a technique called bindings, no? And we create a wrapper around the C library that we create from Waku. And this is the example of the bindings of this wrapper around Dart. And Dart is the language that is being used within the Flutter environment. And let me, before going there, let me just share. This is the NIM Waku repository. And what I'm sharing here is the header file that we expose nowadays. And there are many functions, and the implementation starts from this point. And if we look at the how the bindings is implemented within the Waku Dart bindings, is relatively straightforward compared to other bindings that we've implemented. For example, for Rust or Golang, the Dart bindings is much more simpler by just implementing this in a single file. As you can see, very short file. We just are able to integrate a bunch of libwaku functions, particularly the Waku new, destroy, start, stop, etc. And okay, and the main important thing to bear in mind is that these Waku Dart bindings is a wrapper, and we need this to be a package to be consumed by any other Flutter/Dart application. And in this particular Dart application that I was willing to implement, but I didn't have time to have something more mature. What it does, it has the Waku Dart bindings repository as a dependency. Now I have it extracting it from the local folder, but it can be consumed from GitHub repository, and you can specify the commit you are willing to consume. And without further comments, let me try to open. This is the example for desktop, and just as an example, okay, very simple application, and we can start the Waku node. And well, it doesn't do anything very fancy, but just starts the Waku node and helps to deal with it. So far is mounting relay protocol, so that is still more work so that it mounts or it handles edge protocols like light push and filter. Okay, and something else that I wanted to show is the Sorry. Something I wanted to show is the example on Android. This is my mobile, and if we come here, we can, if we set Flutter devices, we can see this is my mobile phone, and we can debug right away in there. Sorry. And well, it will take a while, and while it gets in the meantime, meanwhile it gets deployed, I want to share that the Waku bindings, the Waku Dart bindings, what it does, it nowadays have the the library hard-coded in the repository, which is not great, but for the demo is enough. And we have different library versions for every Android architecture. And yeah, as you can see, this is the okay. The node, the nwaku node is started within the, and as you can see, we have the name Waku nodes from the mobile phone. And yeah, that's pretty much I wanted to share regarding the application. Yeah, the takeaways is that it's relatively easy to integrate Waku or any other NIM library within Flutter. And it's pretty convenient because having one single code base, it allows to implement both desktop and mobile applications. Yeah, well, of course, there is an outstanding implementation in the application that I wanted to implement, but yeah, that's very much of it.
All right. Thank you, Ivan. Panelists, your questions, your feedback.
Yeah, if I can go. Look, I really like the idea of building this block for Flutter. I would say definitely continue this one. The more building blocks we build, Waku building blocks we build for well-known frameworks, I believe it's gonna spread and really boost Waku adoption. So I kind of don't see any drawbacks not to do it, really. And yeah, from my end, I believe that's a really great initiative. Yeah, that's it on my end.
If there is no other questions. Oh.
So Flutter, we did have, I think last year we had a couple of requests for Flutter. So I guess my question would be, I mean, let's talk about it, but like, it seems like it was pretty easy to put in place because you did it this week and you told me that you didn't have a lot of time to do actually a hackathon. So I wonder, is there much we have to do to kind of make this easy for any developers to jump in, or is there a lot of hacking around and you'd be costly to streamline?
No, I think it's very, very easy to have or to extend the Waku Dart bindings. Once we have a more mature API, etc., I think it's going to be straightforward to extract it. Yeah, I got super surprised about how relatively easy it is to integrate compared to Rust, for example. Particularly because in the way how we interact with the library, which is by the callback approach, and it handles it very well. So yeah, it was a very, very positive surprise.
Awesome. Cool.
Very nice. Thank you, Ivan. We have Sergey up next. And I will bring Sergey on and say goodbye once again to the panelists for the moment. We'll see you all in 1 second. And without further ado, Sergey, the stage is yours.
Thank you, Chair. Thank you, everyone, for presenting and discussing today. So my short presentation will be about CloudMD. So the idea, again, thanks Chair Anderseni for the idea itself, is to provide a file that gives some assistance to AI assistants. So this is version 1, and largely AI generated, admittedly, may contain mistakes, and I will invite everyone in the end to review the PR that contains the file. So what is actually CloudMD? It's a text file, both machine readable and also human readable, I might add, written in simple markdown, that provides necessary context to help AI coding assistants such as Claude, but not necessarily, to help with coding. So it is read by LLMs, and it is emerging as a practice in development. So as far as I can tell from my quite limited experience, AIs are quite smart, but one thing that prevents them from delivering good and reliable results is lack of context. So some things about the projects that the developers understand, the LLMs don't understand unless we give them this information. So hopefully this file will provide faster assistance from AI, better suggestions, and more consistent suggestions with respect to our architectural decisions, our style guides, and best practices that have been established earlier by human developers. So currently, the CloudMD file, the first version, contains this many lines that describe identity of the project being Waku, the architecture, some essential commands to run and test the project, and some conventions that have been established. And this file has been largely composed by AI as well, under my supervision. And the sources for this file were the style guide that we have, the status name style guide, the RFCs for Waku that describe the structure of the protocols involved, and the existing documentation in the Waku and larger Waku repositories. So yeah, I will just give a brief overview of what the file contains, and then give a link for you to study it if you're interested. So first, we have a few paragraphs describing what actually is Waku. That it's a Waku implementation in name, that we focus on privacy, peer-to-peer messaging, and we target, or at least emphasize, support for resource-restricted devices as our targets. We have a design philosophy, again, compiled from existing documentation. We prioritize resource-limited devices, we prioritize privacy, and we also have sharding to provide more scalability for Waku. There is also an overview of the core protocols involved in the Waku protocol stack and the key terminology that is necessary to understand these protocols better. The file then describes the directory structure. These are not all the directories that Waku repository contains, but again, see full file for the list of directories and what they stand for and what they contain. Again, as a side note here, for LLMs, it might not be obvious, even if they have a good coded suggestion, where exactly to put it, into which directory or subdirectory and whatnot. And again, helping AI understand our practices makes this process more efficient. Then we have a few developer essentials: how to build the project, how to test the project, how to format the code, what formatter we use, and how, and other necessary things. Some code conventions regarding naming, how we name files, how we name procedures, how we name types. Although I would assume that this can be deducted from existing source anyway, but probably better to provide explicit context anyway. Some error handling advice, again, extracted from the current guidelines and best practices, what we use for asynchronous procedures, how we use result, how we use exceptions, and where. Provide some context. Again, some examples of the style guide advice that have been extracted from the NIM style guide. Prefer functions, prefer more restrictive types of variables such as const and let, immutable variables as opposed to var, if not necessary, stack versus heap, and sequence of bytes for binary data. Some common workflows are also covered, such as how to add a new protocol to the Waku protocol stack that we as developers and AI as our co-developer should create the directory for that protocol, define some core files, again with their own naming conventions, and mount the protocol within the Waku node. Some notes on dependencies about the vendor directory that contains the dependencies of the project, logging, memory, and the fact that RLN is implemented as a Rust library. Therefore, we need the Rust toolchain also to be within Waku. Yeah, so this was an overview of the contents of the file. The file itself is in the open pull request to the Waku repository, pull request 3624. And I invite everyone to have a look, especially if you are involved in the development of Waku. Please have a look to make sure that there are no mistakes or there is no hallucinations there, because to be honest, I don't have a deep understanding of everything that is written there. That's why it's not yet open for review. It's like draft PR for now. But I hope it will be useful anyway, both for machines and also for human developers, because having a relatively short introduction to our best practices and the core structure of the project looks useful in its own right. So, yeah, I think I'll stop it here, and I'm happy to answer any questions.
Yeah, maybe if I can, go first. I really like this idea. Look, that's awesome to build this project to provide the context to LLM. That's, I believe, what kind of the key thing whenever you start to use AI. That's the thing that you need to take care. If you feed it the right context, you're gonna get a way better results. And from what I've seen, I believe it's well invested time to build out this project and try to see. I'm curious if you maybe already thought about measuring the result, right, with and without, and if you see kind of a difference between when you feed this context, how actually what help and results you get from LLM and resulted. That'd be also nice to kind of to see, understand the level of improvement.
Yeah, yeah, thank you. I must say that I thought a little bit about potential benchmarks on measuring the effect. but didn't have enough time to actually implement anything on that front. And I guess the difficulty here is that these, like, the effects of such a file can be more of a subjective developer experience rather than some objective metrics. Or maybe the objective metric might be how quickly developers implement new features. But again, to measure this scientifically, we have to compare like apples with apples and
I see. Yeah,
come up with
that
some
makes sense.
framework of measuring. I mean, this is hopefully it could be useful, but again, maybe requires some extra effort to
Got it.
test.
Yeah, totally understandable.
Any other questions from the panel?
No, I think I can measure it, yeah, because as you say, pick a simple feature and get code to build it with and without it, right? And see what happens, right? Especially for the code can be quite good at just getting the test and the code and everything. So I think you should try with a small feature. What I was wondering is, like, as you were looking into that, what kind of was there any best practice that you came across that was new to you or maybe surprised in terms of like what you had to put in the file?
Yeah, kind of difficult to say. So my idea was, or at least like that's what I tried to prompt the AI to do, is to include in these files first like the most fundamental things that are necessary to describe the very general overview of what the project is, and also the rules that are not obvious or perhaps violated most. Although I'm not sure I have the expertise to judge which rules are most often violated, and AI may also lack this expertise. But I asked it to do it, and it does make sense on the first glance. But again, it might be the case that some more important rules have not been included, and we'll have to expand the file to include more rules. And I don't know, perhaps another like thing to think about that just came to my mind is we have the whole style guide, and strictly speaking, we could feed the LLM the whole guide, and the guide is quite well written and quite concise. To which extent do we need the extraction from the style guide in the form of even shorter, like one sentence description of what it takes a page to describe in the style guide? I don't know, but this this could save us some context tokens. Don't have the answers really, so it's like an invitation for more experiments rather than a ready solution.
No, good. I mean, I'm probably going to. I'll try it out for next time I do some name changes. Actually, I have an idea I want to do, so that's great.
All right. Any other questions or feedback? Roxana? Yeah, so I waver back and forth between one massive Claude MD file and breaking things into chunks and having like a design instructions file and a framework specific file and then a specific Claude MD instructions file. I think lately I'm more in just a massive catch-all Claude MD file with appropriate sections. Interested to see what Arseni also has coming up in the next demos session. Well, folks, thank you to Sergey and to Ivan and to Fabiana for presenting today, and to our panelists for their feedback. Thank you, everyone, for joining the first demo session of the second Waku Internal Hackathon of the year. We have another session coming up in just a little under 4 hours. wherever you're watching, if it's YouTube or X, if you could like and subscribe and follow and retweet and turn notifications on. Visit us at logos.co and waku.org. We'll see you in the communities very soon.